All right, I'll start with a question. Who owns security in your company? Is it the security team or is it the engineers? So I would like to welcome you to the world of developer-driven security, where the engineers own it, because high-quality code is secure. And in this world, each pull request has an associated Jira ticket. Jira ticket has an associated Jira epic, and each epic needs to have a security review. Okay? In this world, it takes less than 5 minutes to do a risk assessment to tell whether a given feature is low, medium, or high risk. It needs to go through threat modeling, or whether it needs to go through a pen test. I mentioned threat modeling, which is done by the engineers. In our custom tool, with a bit of automation, you will see that. Threats and mitigations are stored as code, as gherkins. So they are machine readable, and they're stored in a database. Exact line references for security mechanisms. So for example, if the threat is malicious input from the user, the mitigation is validation this against a specific format, then the security mechanism, the function that actually validates the input, is referenced in that threat, is attached to that threat and mitigation. So you've got threat, you've got mitigation, and then the validation in the very same place. And in this world, the product security is directly involved only in 10–20% of the security reviews for any given feature. Okay. So I'm Jakub. Spent over a decade doing security consulting in Poland and in Australia. Done hundreds of penetration testing projects, of threat modeling sessions. I'm an author of Instant Threat Modeling series. This is a 5-minute video series on security. I've already stopped publishing those because I changed jobs. So now I do security at Snowflake. I'm leading one of the product security teams. They're in Poland. Snowflake is based in the US. We're doing the data cloud. So a lot of the things I'll be mentioning today is about storing the output of the security review of any security deliverables in the database. Okay, so the agenda is very simple. I'll show you how we do it, and I'll show you a demo. By the way, the whole AppSec program is a joint effort by all members of the product security team, of course. We've got more than 30 people working on that. So let's start with a simple diagram. What if there was no security at all? The engineers would just push the code, they will make a pull request, land in the code repository, and land in production environment, right? So there is this smart thing called DevSecOps. There are multiple tools that we can attach. We can either scan it manually, or we can attach it in the CI/CD pipeline. So we're talking about SaaS tools, DAS tools, software composition analysis. This is cool. So to our program, let's implement that. Let's add a bit of automation. So we got the tools that are scanning the pipeline. And by the way, I mentioned we've got the database. So here is the key component, and let's make a principle from now on. Every component that we add to this AppSec program, all deliverables, all output needs to be stored in a database, right? In our case, Snowflake Data Cloud. So we've got SAST vulnerabilities, the findings from the software composition analysis, everything is now in a database, as well as GitHub metadata. Okay? So let's introduce some manual review. For some features, we would like to do a security review. This will be done by the security specialist, by the engineers in the product security team, right? So does it look good if every change needs to go through product security? Of course not. So we need to add a mechanism to tell us which features are worth reviewing and which are not. So let's call it risk assessment. Simple questionnaire, maybe a manual process to analyze a given feature and decide, should we do a security review or not? If not, then those features will go directly to code, and let's say it will be 80 to 20% ratio, right? So the engineers are now not slowed down in 80% of the cases, but in 20% they need to go through ProdSec. Does it look good? Let's go further. I've mentioned that each pull request has an associated Jira ticket. So this is true, but the question is, are we storing any metadata about it? So let's dig through it. We've got a PR, we've got a pull request. This is an implementation of a work described in the Jira ticket. That Jira ticket has at some level of aggregate something that we want to plug in. So we don't want to plug in for every subtask or every task. We want to plug in at a level that we can do a meaningful security review. So it should cover more components or a little bit wider part of the code. But again, it should not be too high because I've heard this at one presentation at AppSec that we should do very little and very often. Okay, so let's decide it will be a Jira epic. Now, we got a gift from our release engineering team that for other reasons, they wanted to have a merge gate. And this merge gate does not allow to merge a PR if it doesn't have a Jira ticket in the PR title. Okay, that's a great gift because now we can actually have a SQL query and make sure that all of the Jira epics, they have an associated security review, right? We can show this data in Jira. We can show this data in the dashboards. Okay, so now every PR is linked to a Jira ticket. Cool. We couldn't done it by ourselves. The product security teams do not scale well. You know, there is so little of us. So let's introduce security champions, okay? We call them partners. And now this mechanism that tells us whether a given feature should be reviewed or not, additionally, it will tell us who should review it. So maybe for some specific features, medium risk, or for other mechanisms that would tell us, will allow the security champions to actually make a decision and suggest some threats or mitigations, right? Do a security review. So let's say 80% will still go through without slowing the engineers down. The 50% of them will go through the security partner, and still the key high-risk features will go through the product security team. Okay. So let's extend it. Let's introduce autonomy levels, because we've observed that there are new teams joining, there are new people getting hired, there are new security partners, and there are also experienced partners, and they are, you know, they're more experienced in doing security reviews. So we need to introduce autonomy levels. So we have 3 autonomy levels for partners and for teams, and those autonomy levels define how autonomous are the teams and partners in regards to the 3 deliverables. So it's actually like 3x3 matrix. Deliverables are risk assessments, threat models that we'll mention in a moment, and validation. Okay, so we've got multiple autonomy levels and we've got an approval scheme. So new teams will require a review from ProdSec on the risk assessments, right? But for example, experienced teams will require only a review from a security champion. Okay, and we've got also the teams that focus on the key components, and they're actually security teams, product security and few other. And they're so autonomous that they can actually go further with this process. So get an approval, get a security review, just with a peer review within their team. Okay, so we've got an approval scheme. And by the way, all of these autonomy levels, all of the approval schemes are stored in a database. And you see that green color, the database gets filling in. Okay, with complication of the process, we need to introduce some training. So we do training for the engineers, for the security champions, of course, for new product security engineers that need to perform these reviews. So we make this training, documentation, written documentation, video trainings, and these kind of things. Because we have mechanisms, we make it, for example, obligatory for the new hires. And the results of the training, so the completion data, again, we store in the database. We'll use it later. And we have other data in the system, because it's not only product security that stores everything in the database, it's all other teams. So we've got the employee data, information about who joined the company, who they report to, who is their eng manager, so we can build alerts. So now we have We have a SQL query that tells us how a given team, what's their ratio, like what's the ratio of the engineers to the security champions. We have alerts that tell us, oh, this engineer left the company, so maybe we need a new partner, right? So this is an automatic alert based on a SQL query that opens a Jira ticket or sends us an email when some action is needed. All right. Now, I think this is the key part, one of the key parts of the system that really sped up the whole process. So custom risk assessment templates. Okay. First, the risk assessment questionnaire was generic, was the same for all teams. But when we introduced custom risk assessment templates, this changed everything. Because now we don't ask front-end teams the back-end questions. Some teams work with front-end technologies, with React, right? With whatever, Node.js. Other teams work in the core SQL engine. They do in C or C++, right? Some write software in Java. So we need to ask them specific questions about their specific work, and then they can actually go through this questionnaire in like less than 5 minutes. The best thing, these questions are owned by the engineers. So like it is a machine that tells a given feature is a low, medium, or high risk. It has also some other features I'll describe in a moment, but the engineers own the machine. We have some expectation about the machine. We have some expectation how many of these features will go through low, medium, or high tunnel. We, for a given feature, will always tell them if it's low, medium, or high risk according to us, but they own the questions. We need to review them, of course, to make sure that there is a path to low, a path to medium, a path to high risk, but they own the questions, and they change it in a database or actually through pull requests to our repositories. Okay. So I've mentioned a few steps of the security review. The first one is risk assessment. The second one is threat modeling. There is the third one I will mention in a moment, but we start these phases based on the risk assessment questionnaire. So if the risk is low, we still go to the code and directly to production, right? Of course, with unit tests and functional tests. But if the risk is medium, we start the threat modeling. And threat modeling, I've mentioned, it is done by the engineers. So let's say 70% of the features will be low risk and 30% of them will be medium or high, and they will go through threat modeling. So how we do threat modeling? We've got few methodologies, few tools that we join together and make this machine and put it in a custom tool. So we've got TM tooling. This is our custom tool, really simple diagramming software. We're using Stride, but also we're using some custom rules. So I'll show you what are these custom rules. So we've got custom tooling for diagrams. We've got something, prototype for that is actually Stride and RTMP by Jeffrey Hill. This is a really good concept. RTMP speeds up threat modeling because you don't need to analyze all 6 Stride categories for each connection between 2 entities on the diagram or for each entity. For example, information disclosure happens when there is a data flow from a higher trusted element to the lower trusted element. So RTMP has this set of rules. I really invite you to read the RTMP docs. So all the engineers need to do is draw the diagram and mark the zones so that we can apply custom rules. Okay, and we store output of the threat modeling as code in Gherkins. So what are Gherkins? The prototype for that was, again, materialized threats. So this is a concept to create boilerplates for a given threat, like spoofing, tampering, etc. Create a boilerplate. So we generate technically everything except of part of the last line. This is a boilerplate for spoofing. So given a process causes data to flow from source in a specific zone to the destination in some specific zone, then when the source attempts to impersonate something or someone else related to this process, then we generate these mitigations. So implement and validate digital identity by, and this is where we expect the input from the engineer. So for example, no, the example will be later. So, but an example would be tampering threats, expecting malicious input from the engineer, then the mitigation is then validate, treat all input as malicious and validate the input against the specific format specified in whatever, this ticket. All right, so this is the end of the threat modeling phase. We've got a gherkin for each threat. They've got a specific structure, so we can actually parse that. We can query that with SQL. And this is where the threat modeling ends. So there is the approval scheme that tells us who needs to approve a given threat model. Is it just a peer review within their team? Is it a security champion partner? Is it product security? And of course, majority of the teams now, they require a review on threat models from the product security team. So this is where we make sure that the quality is maintained. Okay? So now, look what we have now in the database. In the database now, we've ran this program for 2 years. In the database now, we have hundreds of security reviews, thousands of threat models, thousands of diagrams. Maybe hundreds of diagrams, but hundreds of the entities on the diagrams and thousands of gherkins. This is amazing for the analysis. Okay, so the next step, the third step of the security review is the security validation. The threat model is nothing if there is no action, if there is no follow-up action, right? So we need to write the mitigation, the security mechanism that actually implements the mitigation. So let's do a validation and let's do one more thing. Once the security mechanisms are implemented, let's ask to link them to the threats in the gherkins. And this could be a line of code, specific line of code where this is implemented. For example, a link to GitHub lines. It could be a link to a pull request with multiple commits. If this is not in the code, but it is somewhere in the configuration, another proof that points us directly to the place where we can confirm if this is validated or not, and if it is validated in a good way. So, in the end, the security review, we have the Jira ticket with the explanation of what is being built. We've got the diagram, the risk assessment questionnaire, the risk level, the diagram, the threats, the mitigations, and specific lines of code where this was mitigated. Okay. Sometimes we want to run a pen test. So the question is, for which features do we start a pen test? So high risk features that the result from the risk assessment are good candidates for a pen test. So we're doing a pen test determination and define which features should go through the pen test or not. Okay. Once we have the pen test, we have vulnerabilities, and vulnerabilities come from multiple sources. Pen tests, tools, static code analysis, vulnerability scanning, all of these kind of sources, and all of these sources integrate with the database. So now we can do interesting, cross-component analysis. Which teams modeled the threats? Which teams had a lot of mitigations? Was this vulnerability in the threat model? We can query. We can have a dashboard of teams with an SLA of the vulnerabilities. All of this kind of database magic. Cool. So I've mentioned these are the dashboards. We can build dashboards with specific violations. So violation of the process. Have someone push the code even though there was no security review. We can do a violation of an SLA. So these kinds of dashboards, for all of this, you need to be available. There is a lot of soft skills here and a lot of culture change. So we need to be available for the engineering teams. So we do offer consultation. We do offer office hours. We've got monthly catch up with the partners, all of these kind of things. But I think one of the most important things is that we have an audit trail. So we exactly know what happened when, because everything is either in GitHub or it is in the database. So we have timestamps for each activity, when the threat model was completed, when was the code merged in the repository, right? Okay. And now we can, on top of this, we can build even more interesting stuff. For example, let's say that for some specific questions, we would like to automatically apply security requirements even without modeling the threats. Are you processing PII that includes credit card data? If the answer is yes, then you can automatically apply a security requirement to make sure that PCI DSS requirements are met, these kind of things. Some questions may also imply triggers for other teams. So if the question was about PII with credit card data, compliance would like to need to know about it. And they are flagged as a required reviewer on GitHub for this particular security review. Okay, so other team triggers. These are all elements of what I can share. Okay, there are more interesting projects that we're working on, or we've already finished, or we've started thinking about it. But I hope that you can see the potential. I mean, the potential of, if you have everything in the database, if you have the data, you can build amazing stuff on top of it. I hope that at some point I will be able to share it. Okay, so now a big demo. One more thing. The whole database concept, keeping everything in the data cloud, and ability to cross-query all of this information can be called AppSec Data Lake. So this is an idea by Jakub, who is actually leading the product security team at Snowflake, all product security teams. So the concept of AppSec Data Lake it's a data lake with all of the AppSec data. What does it mean? It means that you can execute all of the SQL power and you have thousands of data points. So you can select from teams where the partner ratio is more than 7-to-1, right? You can select all risk assessments where the risk was high, and you can automatically integrate with Jira and create a ticket for pentest determination. You can select the teams for a given security review and automatically flag the required reviewers in GitHub. And you can build a violation dashboard on top of that. Okay, more than that, you can select the threat models where there was an entity, a specific instance of web application, something like that, that was that had a vulnerability of a high impact, and it is in the database of in a table of vulnerabilities. Okay, then you can group all of the vulnerabilities by category, order them by number of vulnerabilities, and then for the most common vulnerabilities, what are your priorities for creating new training for the engineers. Okay, sounds good. So now I'll show you a demo. Fortunately, I can't show you it live, but I'll show you a few screenshots. So this is the risk assessment screen. You select your team. Let's say we're in product security. Then we enter the Jira ticket ID and the description of the project. This actually can be automatically copied from Jira. Then we have two interesting questions: which other teams will be impacted, and which other teams depend on this project. Then we can either ask the questionnaires from these teams or simply mark them as required reviewers. Say a software team needs a kind of infrastructure from the cloud engineering DevOps team, so they rely on the DevOps team. Okay, and which technologies and frameworks the project will be utilizing. So now we can select either internal technologies, or we can select frameworks, libraries, React, C++, some technologies. And for these specific technologies, either we can flag the team who would like to be flagged on when this happens, or automatically generate some security requirements. Okay. So here are the questions. Some questions imply other questions. So 7 and 8 was generated because the answer to 6 is yes. So do you want direct security involvement, and do you want it from the product security team or from the compliance team, right? And every question has an associated risk level. So, for example, if there is a requirement of direct involvement from the security team, it is usually a high risk. Okay. We can ask specific questions with corresponding requirements to speed up the threat modeling part, and actually making a validation for the security requirements from the risk assessment lowers the risk for a given feature, because the identified risk was already mitigated. Okay, and of course we need to have a path to other risk levels. So low, medium. So we've got other questions leading to medium risk. So this is the next screen. We've got the risk calculation and we've got the security requirements. For example, there was a question about privileges. Are you trying to change the privileges scheme or something like this? Then we've got a requirement 38. It says changes to RBAC must be documented according to some policy. And you can actually link to the policy here. Okay. Or creating a new cloud resource requires an approval from this and that team. Okay. They can either, the engineers can either accept the requirements, or they, for some reason, if they won't do it, they can give an explanation why, because something. So when at this moment, when the engineer clicks complete, there is a pull request to GitHub so that the required review is flagged in GitHub. And all of the output is also stored in a data cloud. Oh, I knew it. Video can't be loaded. Yeah, in this case, I will just show you the screenshots because I'm prepared and it was in my threat model. That's our example threat model sandbox. So this is the screen where they draw a threat model. So adding entities, adding data flows, the rectangles or entities, the circles or data flows. The engineers fill in the zones. We've got a training for them how to do it. So the zones are in blue. And then they click generate threads. They also have some other buttons, like they can check if the linting is good, if all of the components on the diagram are connected to each other. So then they click generate threads, and we generate stride categories that apply for given entities on the diagram. So in case of an engineer that is drawing a diagram in the tool dev portal and the output is saved to the database, we only consider elevation of privilege here, tampering, spoofing, repudiation, elevation of privilege here, and we don't consider, other threats that otherwise we would need to consider. Okay, for each of those, we're generating. Okay, one more. We can mark some items out of scope. If they're important for this discussion, they should be on the diagram. But if this is a part of a given or another feature, then we mark this out of scope. And threats for a given item that is marked out of scope is they're not generated. Okay, so now these are the boilerplates. We generate the scenarios, and we already fill in everything that is until the middle of line 5. So that is the mitigation. So here, if there is tampering, then we should treat all input as malicious and handle it safely by validating. Okay, and this is where the engineer fills in the gherkin. We can also link some references to documents that are worth mentioning in this case. Okay, so that's it for the demo. I hope you liked it. I'll mention one more thing. Metrics. With all of the data in the database, in the data cloud, with something we call AppSec Data Lake, you can actually create new metrics by just coming up with a new SQL query. So think continuous maturity assessment as SQL query or validation, right? You don't fill in the SAM questionnaire once a quarter or once a year. And also this data is in 3 levels, right? 0, 1, 2, or 4 levels. We've got numeric exact information. How is this going? So these are a few screenshots from the training and education dashboards, maturity. We've got training completion by cost center, training completion by time. This drops in the completion. There are probably either new training being developed or acquisitions where a lot of people join in one day. Training completion by module, visualization of the training completion by module. So this is it, continuous maturity assessment. So it can actually help to drive the program in the right direction. Like we've got the A+ state defined. This is where we want to go. We want, for example, this value to be 80% or whatever the ratio we want for the security engineers. If this training is for the security champions, there is 13% of them in the company. We want to probably this value to align to 13%, right? Cool. So that's it. don't have a summary slide, but I'd like to mention 3 things that are important to build a program like this. The first one is data. Without the data, you can't achieve it. And without a way to store the data, you can't query and you can't cross-check connections between different elements in this program, right? The second one is data. And the third one is data as well. Okay, thank you very much. And I left a lot of time for questions, so if you have any, please.
Q&A. Gentlemen first.
Yeah, there. Have you thought about using SCA to detect positive attributes in your code? So if you've got a standardized encryption library or data cleansing library or something like that to reduce risk automatically through SCA?
So scanning code and defining.
So using something like semgrep, but instead of looking for vulnerable code, looking for the presence of good code, good activities. Like, you've got a standard encryption library. It has, whatever strength by default and all the rest of it. And then using that to say, well, they've met this security control and de-risking. Yeah. I think in one of the documents, in one of the blog posts we've already mentioned, we're using semgrep. So yes, these kind of ideas are constantly being discussed. This is an interesting concept. So matching code back to the like maybe even threat models. Yeah. So basically, you know when a threat has been mitigated either through a secure control pattern or whatever.
Okay. I can't answer the question.
Jacob, I had a question. So in your in the questionnaire, in the risk assessment, you asked, I think it was question 6, do you want security involvement throughout the process? But surely the temptation there for people who want to rush through changes is to say no, and I don't want any oversight. So how does that work in reality?
That's the opposite. It's actually the opposite. So the engineers overuse that function and call us very often. That's because they want to make sure the engineers own it. So they actually understand that it's on them to make sure this solution is secure, and they don't want to rush. They actually want, ideally they would like to get a green light every time from the product security team, right? We can't provide it because there is not so many of us. So it's rather the opposite, but usually they've got a specific reason why they would like to do it. For example, they don't know how to choose the right cryptography for storing the tokens, right? Or something like this.
And has it always been like that for you, or has that been a culture shift?
So I joined the company a year and a half ago. Some parts of this process are running already for 2 years, and actually the work to shift the culture probably started even earlier. There was, I assume, the work done to convince, all of the engineering leadership, then the eng managers, the engineers, to work this way. I assume it was a lot of work, but now we capitalize on this, and the engineers are actually happy with this approach.
Thank you. Other questions, please? There was. Thank you.
I actually had 4 questions, but I will ask you just 2 for the sake of giving other people opportunity. I was wondering how incident response actually fit in this model. Is also data artifact that you can backtrack? For instance, let's say you got an incident, something got compromised. Can you backtrack with data to see if that can be fixed? Yeah.
So in case of an incident, of course, some work needs to be done, and a lot of this work is manual to actually track match a situation, a vulnerability, a HTTP request to the specific part of code that implements it. But once we track which part of code is it, then we can, based on Git history, we've got the pull request that implemented this part of code. And if we had the Git history, we can backtrack it to a threat model if it happened 2 years ago. Right?
Okay. And the last question is, what mechanisms do you guys have to keep the risk forms current? Meaning, I assume there are going to be a lot of corner cases, right? So how do you make sure first, like there is one size that fits all, like this form gathers all the information you're trying to gather, and to keep that current to new use cases? Yes.
The whole program evolves a lot. So all of these components and also other parts of the AppSec program are constantly evolving. So like each quarter, the whole assurance team defines the project for the next quarter. So we try to improve it every time, right? So yes, changes are necessary. And of course, we need to collect the feedback from the engineers, from the managers, what's working, what's not working. We've been changing, the risk questions. We've been changing the way we present who needs to approve a given review because it was not clear. So we're constantly evolving this.
Thank you. Any other questions?
Yeah. I think I can
So go to this lady here.
Jakub, I see more and more blogs saying we hit the ceiling tying things to pull requests. It stopped scaling. It takes too much time to run our security checks tied to pull request. We had to build some kind of out-of-band security center that checks things. Have you hit the ceiling yet?
No, at this point, we've got around 1,000 engineers. Number of pull requests this is a lot, but we apply security review for epics. So usually an epic is divided into tasks, into subtasks, and if I would try to estimate how many times a given team needs to go for a security review, it also depends on the team. There are teams that deliver a large number of small features. There are teams that deliver a smaller number of bigger features. But let's say on average, a team of 7 to 10 engineers with one champion they need to go through one security review every sprint, every 2 weeks, something like that. And it takes 5 minutes for the risk assessment. On the threat model, it depends on the situation. Let's put it 1 hour. So the whole investment, we've been estimating this. It's not easy to estimate even with all of this data, but it's probably 2% of the whole engineering time. We think, one more comment. I think everything we build, this is another principle. Everything we build, we need to be ready for like a 10x growth. So I think we can easily go with this and grow 10 times from now.
Cool.
Yep.
When do you do the risk assessment? So let's assume they have what's it? It could be collaboration issues or timing issues or issues. How do you handle that?
So if they answer yes in the question that they need a direct involvement from the security team, we're flagged on GitHub. And also we've got a consultation system, office hours every week, a few times. And they can also reach out on Slack. So security, we maintain good relations with the security champions. We meet them regularly so they know who to reach out. So usually the path is that the engineer, if they have questions, they would first discuss this with their security champion. And then the security champion, together with the engineers, they would reach out to us through a consultation, through office hours. We've got engineering offices in US, in California, in Canada, in Germany, in Poland, in Warsaw, where I'm based. So we also have people, in each time zone, so that they've got local support. And this is how we're solving that.
So when you're creating the threat model, how will the PR work? So when somebody has to push the code, then come back, there is a PR link, and there is a separate PR.
Yeah. So the threat model is a pull request to our repository. It has all of the metadata, not only the image, this is the SVG, but it is also the connections between specific edges on the diagram. So this is a pull request. It is a file in our repository. So when they are adding the validation, currently they are adding this through GitHub for a pull request to this specific file that was created earlier on.
Cool, thank you. Go to the next question.
This is similar to one of the questions I was asked already. It's in relation to, you said that when there's a pen test, they might look for what's identified in the threat model, or is there any then kind of feedback loop between the pen test and the threat model to see, well, okay, we thought that the control was in place, but you can actually bypass it, or we didn't think about this threat and how's that handled?
So every pen test, as an input, they're already getting the threat model with the mitigation, right? We're running, red teaming operations, whole pen test. I mean, like a holistic pen test on the whole solution. Yes, of course, we do run it. Then we need to actually backtrack it to the specific lines of code and then to the threat models. But the feature pen tests, the scope of the pen test is part of the scope of the pen test is actually the threats from the threat model. So by design, we backtrack it, yes.
Cool, thank you. Any other questions? Raise your hand. Cool. I would just like to ask one question, Jakub, actually. On you mentioned obviously the threat modeling process. In terms of actually applying things like Stride within your team, how do you enable your team to actually threat model and actually run through the process? Because it can be quite difficult, right? So how do you upskill the team members in order to actually complete that effectively?
Mm-hmm. So within the security engineering team, we've got our own internal training, shadow on call. So everything related to the security review is part of our on-call function. How we train the engineers, we build written documentation. We build video trainings. So the video trainings are connected with the LMS, with our learning management system. This metadata is also stored in the database. And every new hire needs to go through basic training in threat modeling, or at least in the security review process. And then they've got a fast track. There is one thing that I didn't mention. There is a fast track to go with super low risk features. There are many of them. And the only people that can use it, there are those who completed one of the trainings in our LMS.
Thank you very much. Final questions from anyone in the audience? No? Okay, well, thank you very much, Jakub. That was wonderful.
Thank you.